Hello, welcome to this video that covers exercise 2D, question 2 of the AS Mechanics and Stats textbook. So this question here, we're looking for the 34% and 66% interpercentile range. One thing that you should always do to check is to check your classes, to check whether they end and start at the same value or there is a gap between them, because if there's a gap you would need to change your class. It would be a good idea to change your classes so you know your lower class bound and your upper class bound. Here we can see that it's the first class ends at 1,000 and the next class starts at 1,000. So therefore the classes that are essentially the monthly income, the lower class bound is obviously below on the 900 and the upper class bound is 1,000. And just knowing that fact means that you will not make a mistake when you're doing your calculations. So the first thing we look for is we're looking for the 34% and 66% interpercentile range. To start off with, we need to find the total frequency because we need to find where the position is of the 34% of the total frequency. So step one is that we find the total frequency. So the sum of the frequencies is 3 plus 24 plus 28 plus 15, and that's equal to 3 plus 24 plus 28 plus 15 is equal to 70. Now probably a quicker way is to make just a new column in your table. This is not a helpful question for this, but if we do community frequency here, we've got 3, 27, 27 plus 28 is 55, 55 plus 15 is 70. So if you want to find the 34%, the first thing we do is we find what is 34% of 70. So 70 times 0.34 is equal to 23.8. And to find the 66%, we do 70 times 0.66, which is equal to 46.2. So these tells you the positions along of where the 34% and 66 percentile is. Again, there is two methods for this one, very much like question 1. So there is the ratio method and there is the formula that you can apply directly. I'll do each of them. So the first one we'll do is the formula for the 34%. So for the 34% part, what we're going to do here is we're going to use our formula. So to find the formula, we use our lower class bound plus the width, so the class width, and then this is times by your value, so essentially the 34% value, minus the cumulative frequency of the previous class divided by the frequency, or the class frequency. Okay, so first of all we need to determine which class it belongs to. So here 23.8 will belong in the 1,000 to 1,100 class, because this class finishes at 3, this class finishes at 27, so it must be within this class as it's lower than 27. So if we fill in the lower class bound of this class is 1,000, the class width is 100, 1,100 minus 1,000. The 34% value here is 23.8, so it's going to be 23.8 minus the cumulative frequency of the previous class, which is this value here, 3, divided by the class frequency, which is 24. From here we just plug this straight into our calculator. So it's 1,000 plus 100, 23.8 minus 3 over 24, and that gives a value of 1086.7 to one decimal place, and then and that's it. So that finds you your 34% value. For your 66% one, we'll do the ratio version of it. So for the ratio, remember that we take either side. So the first side is going to be your class, and then your second side is your frequency. So here what we're interested in the value x minus your lower class bound divided by your class width, and that's equal to your 66% value in this case, minus the cumulative frequency of the previous class, divided through by the frequency, so the class frequency. So again, either method is valid. Some people prefer each one, so I'll just show both methods, but again, you can just use the formula here to calculate it. So here x is what we're trying to find. The lower class bound, so here we need to determine the class bound, which class we're in. So if we're at 46.2, again that's above 27, so we move to the next class and it's lower than 55. So it's going to be in this class for the 66 percentile. So from here we've got x minus our lower class bound, which is 1100, divided by our class width, 1200 minus 1100 is 100, and then the 66% value is 46.2, minus the cumulative frequency of the previous class. In this case it's going to be this value, 27, divided through by the class frequency, which tells us in the question is 28. From here we just solve, so it's going to be x minus 1100 is equal to 100, and then 46.2 minus 27 divided by 28 is 24 over 35, and then from here we just say x is equal to 24 times 35 times 100 plus 1100 gives a value of 1168.6. So this gives you your 66 percentile. So then from here we want to find the interpercentile range, so that's just going to be the 66% value minus the 34% value, so it's 1168.6 minus our 1086.7, and then we just plug that into the calculator. Again, in terms of reducing it, anything above 3 significant figures should be fine. So in this case here we get 81.9. So that is our interpercentile range. Obviously here the percentile range is in pounds, so it's always good to put some units if you can, and the units you use is whatever the class is. So here it's monthly income. The next one that we have is estimate the number of data values that fall within this range. So question B, so in terms of the data we're looking at the frequency. So here we have so in terms of the frequency at 66%, it's at 46.2, that's what we found before, and at the 34% value we have 23.8. So essentially each one of these is a data value. Obviously we're only really interested in whole ones because obviously you can't have part of a worker. So essentially what this question's asking for is asking for how many workers does falls between the 66% and 34%. So if you had them all in a line, you would start from the 46.2 worker and then subtract the 23.8. So here I would just do the subtraction as it is first, and then do the rounding later on. So you've got 22.4. Now again, you can't have 0.4 of a worker, so you're going to have 22 values, or in this situation, if it has to apply it, 22 workers, because that's what your data value and your frequency is, essentially the number of workers. Okay, let's have a look at question 3, a very similar type of question. A train travelled from Lancaster to Preston. The times to the nearest minute it took for the journey were recorded over a certain period. The times are shown in the table. Calculate the 5% to 95% interpercentile range. So for this question, again, we start with cumulative frequency and make a column and we go ahead. So the first one is 5, the second one is 15, then we do 15 plus 35, which is 50, and then the final one is 60. So we've got 60 values altogether. So first of all, we find what is the 5% value. So 60 times 0.05 is equal to 3, and the 60 times 0.95 is equal to 57. Okay, so that tells us what our point is we're going to start with, and then what we're going to do is for each of these we're going to find the value. So to find what essentially the minute is for the third person, so the idea here is that we equally spread them out, but there's one thing that I didn't do here, is I now need to look at my class width. So here we need to be very careful because we notice that the last value of the one class is not the first value of the next class. So that suggests then that we need to be careful because our actual lower class bound and upper class bound is going to be minus 0.5. So here it would be 14.5 and here it would be 16.5. Remember that, for example, if you had a journey time of 16.2 minutes, that would round down to the 15 to 16 class. And then anything above 16.5 rounds up to the 17 to 18 class. So we need to fill in the lower class bounds and upper class bounds. Again, if you fill this in at the start, it makes you less likely to make a mistake. It's very easy to miss this. So here we've got our class bounds all set up. It looks a bit messy, but it will save you some time, and you can always redraw the table out. So now we need to find, first of all, which class each of them falls in. So we're going to look at the 5% value. So here, again, we'll use both methods again. So first of all, we do the formula. So it's the lower class bound plus the width times the value, so the 5% value, minus the cumulative frequency of previous class, divided through by the class frequency. And then from here, so the 5% value is 3, so 3 is going to fall into this category here, the first category. So the lower class bound here is 14.5, plus the width of the class is 2, from 14.5 to 16.5. Remember, you include the class bounds for the width. The 5% value is 3. Obviously, we're in the first class, so there is no previous community frequency, so it's 0. Then we divide it by 3. And that gives you the value, so it's going to be 14.5 plus 2 times 3 over 5, and that gives a value of 15.7. So 15.7 is your 5% value. Again, you can use this formula to calculate the 95% value, but I will do the ratio method just to show you how that would work. So 95%, again, you make is the class on the one side and the frequency on the other side. So in terms of the class, we're trying to find x, so it's going to be x minus the lower class bound, 14.5, divided by the class width, so 16.5 minus 14.5, which is 2. And then that equals the frequency, so here the frequency is 3 minus 0 over 5. And then from here we just solve from here, so it's x minus 14.5 equals 2, 3 over 5. Oh no, I'm so sorry. Yeah, ignore that. I've gone away and solving the. No, I'm not doing the 95% one. So apologies. So 95% is 57. So for the 57% one, we have 60. It's going to be, so this class here is 50. So then we need to move it into the next class. So in this case here, again, we're going to find x. So it's x minus the lower class bound. So the lower class bound here is 20.5. Because we between 20 and 21, so x minus 20.5 divided by our class width, which is 22.5 minus 20.5, and that will be equal to the frequency, which we have got is 57, minus the frequency of the community frequency of the previous class, which is 50, divided through by the frequency of the class, which is 10. From here, all we do is rearrange and solve, so it's x minus 20.5 over 2 equals 57 minus 50 is 7 over 10. And then from here we rearrange, so it's x is equal to 20.5 plus 2 times 7 over 10. 20.5 plus 2 times 7 over 10. And the answer here is 21.9. So x is equal to 21.9, so that's the 95% value. Again, I prefer to use the formula, but other people prefer to use the method. You could always flashcard the formula to memorize it. But yes, both methods are perfectly valid. And then we need to find the range. It's 95% minus 5%, which is 21.9 minus 15.7, which is equal to 6.2. And that is your interpercentile range. And then part B, estimate the number of data values that fall within this range. So the number of data values is essentially going to be the number of train journeys. So essentially, we're going to do the 95% value, which was 21.9, and then so up to 21.9 train journeys within 95% of the total frequency, and we're going to subtract away the 5%. So in the 5% one, oh no, sorry, my bad. So we're going to do the 95% value, which is 57. So it's 57 minus 3. So 57 minus 3 is equal to 54. And therefore, there are 54 data values. Here, so essentially 54 journeys were between the 5% and the 95% frequency, or interpercentile range. Okay, last one we've got is question 4. From a large data set, the daily mean temperature for Leeming during the first 10 days of June 1987 is given below. And calculate the median and the interquartile range. So if we're going to calculate the median, we need to put these in order because they're just given to you. So again, the way that you do this is look for the lowest one. So we've got 9, we've done that one. The next one is 10. So we've got 10.3, 10.3, 10.6, and 10.9. So 10.3, 10.3, 10.6, and 10.9, and make sure you cross them off. Then the next one, we don't have an 11, but we do have a 12, so 12.1, then 12.4 and 12.7. So that takes those ones, 4 and 7, and then 13.2 and 14.3. Okay, so that's our values in order. Then we need to calculate the median. So to calculate the median, you can do the old-fashioned GCSE way, start from the end and work downwards. So we just start cross, 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 and cross. And we find that the median here, it's an odd number, so an even number on either side, sorry. So the value of the median is going to lie between 10.9 and 12.1. So to find this one, all we need to do is we do 12.1 plus 10.9 and then divide that by 2. So you're finding the midpoint between the two values, and that is your median for this set of values. So that's going to equal 11.5. And then the next step here is we want to find the interquartile range. So to find that one is Q1. So what we can do is you can draw a line here and essentially do the same thing as we did before, but just in each of the halves. So again, 9.4, 10.9, 10.3, 10.6. And for this one, because you've got an odd number, 5, the value here for Q1 is just going to be the third value, which is the middle number. So Q1 is equal to 10.3. And then here we do the same. So start from both ends, work all the way down, and we're left with 12.7. So Q3 is equal to 12.7. So this is equal to the median. And then our last step is to do 12.7 minus 10.3. And this gives you an interquartile range of 2.4. And that gives you the answer to this question. Okay, so part A is done. The daily mean temperature for Leeming during the first 10 days of May was 1987 was 9.9 and interquartile range of 3.9. Compare the data with May and June. So what I would do is just very explicitly write. So for example here, the median for May is 9.9 and the IQR is going to be 3.9. And then for June, the median, we'll put the column there to make it clearer. So for May, and then for June, the median is 11.5, which we just found, and the interquartile range is 2.4. So for this one, you just need to make a comment. So you just literally compare the median for the first mark and compare the interquartile range. So for June, the average median temperature was higher. Again, use the full, obviously, English language here. I'm just shortcutting it for time. So the average median temperature was higher for June than May. And then we look at the interquartile range. So if the interquartile range is higher for May, so therefore the temperature varied more. So the temperature varied more in May than June, as the IQR is higher. Make sure you're explicit as well in terms of what you're talking about, like how do you know that the average is higher? It's because the median is higher, and how do you know that it's more varied? Because the IQR is higher. So just be very explicit to collect your marks. Okay, the last step we've got is the 10% to 90% range for the daily mean temperature for Leeming during July 1987 was 5.4. Estimate the number of days in July 1987 where the daily mean temperature fell. So for this one, you actually need to know some knowledge outside, which is the number of days in July. So the first thing we know is we should know that there's 31 days in July. Again, be confident, but know the days of the month between May and October for the large data set. It's things like this that can cost you. So if there's 31 days in July, we want to find then 10%, estimate the number of days on which the daily mean temperature fell within these days. So if we're looking at the 10%, so 10% of 31, that gives you, so 31 times 0.1, that's equal to 3.1. So obviously the 10% frequency is at 3.1, and the 90% is going to be of 31 is 31 times 0.9, which is 27.9 days. So this tells you the days between, so essentially we've got the days at 10% 3.1 and 90% 27.9. If you want to find what the estimated number of days where it fell between these days, all you would do is you would do 27.9 minus 3.1. So looking at in the calculator, and you get a value of 24.8. Now for this one, you cannot round up a day. It's like people. So for this one, you round downwards. There are only 24 days where this occurred. So 0.2 of a day, unfortunately, means that the 25th day does not get included in this data set, or in this answer. And that's it for questions 2 to 4. Any questions, please let me know.